All right, I think we can get started. Thank you all for attending our webinar called Burners for Fired Heaters, Fundamentals Part 1. I'm Ashutosh Garg. I'm a process engineer at Furnace Improvements, and I will be your facilitator today. In a few moments, I will hand it off to our speaker, Ashutosh Garg, who will lead the training. Ashutosh Garg will introduce himself, but he is the founder and vice president at Furnace Improvements. A few notes before we get started. We will leave some time at the end to answer some questions. So we want this to be interactive, and we want you to submit your questions. So there should be a button that you can click. It's like a box with a question mark on it, where you can submit your questions. So at the end of the presentation, we'll leave some time to go through a couple of those questions. Another note is we are using a presentation software. So I would recommend you maximize the window with Ashutosh Garg. You can do that by just double clicking him, but the slides will appear right next to him. So that's just to make it a little bit easier for you to see the content. And finally, if you have any questions, please don't hesitate to reach out to our company at the end. And we can help you answer your specific questions about your burners or heaters. You can visit our website, or you can email info@heatplex.com, and we'd love to hear from you. Okay, without further ado, let's get started. Here is Ashutosh Garg.
Thank you, Siddharth. Good morning, everyone in US, and good evening to our listeners and attendees in India. We have been doing these webinars for the last 5 years now. And this is the first webinar we are doing on burners. Burners have been very close to my heart, Just like burners are the heart of our heaters, I have spent almost 50 years in field of combustion. And today I want to narrate to you about 3 or 4 incidences when I was in India about dabbling in burner designs. The first incident which comes to my mind is back in 1980. There was a refinery in India, Indian Oil Corporation in Baroda, Koyali refinery. It was set up with Russians. And they had horizontal fired burners in a pipe type furnace. These were oil fired burners, and they would consume a lot of steam. They would consume almost 1.1 pound of steam per pound of oil, whereas the normal consumption should be around 0.3 to 0.5. The steam consumption was so high that the client was about to put another boiler to meet the atomizing steam demand. They came to our company in India and said, "Can you help us?" And the company I used to work for was very aggressive. And they said, "Okay, we will work on it." And they took the order for supplying 14 burners to reduce the steam consumption. It took us almost, I would say almost like 8 to 9 months to get these burners correct. We were able to reduce the steam consumption, but it took us a long time. Then they gave us a second order, and we were able to supply the second side of that heater also. So burners are highly complicated equipment, even though they are very small in size, but they are highly complicated. The second incident which comes to my mind is our company supplied 3 small air heaters to ACC. And
one second. I think I'm getting some messages saying that there's no audio from Ashutosh Garg.
From me?
Yes. Can everyone hear me okay? Okay, it seems like my microphone is working, but They're having some trouble
my name
from
was
hearing. Yeah. Okay, thank you.
Can you hear
Oh,
me now? No. Okay.
it seems like some people can hear both, but I saw a couple of questions and messages saying that.
Should I do the screen share?
Let's see. Okay, some people can hear Ashutosh Garg too, but it seemed like there was some issues with the audio. Let's see if okay. Let's keep going. It seems like some people can hear you. It may be a bandwidth issue. So it seems like maybe the internet might be a little bit slow. So I think they're saying it's either there's no audio or it's a little choppy. Okay, thank you all for your feedback. We don't want to we want to make sure that everyone can hear the content. Okay, you have to, I think you're still muted.
Okay, can you all hear me now?
Okay, I see some thumbs up. So let's try.
Yeah.
Let's try to continue. And if we have trouble, maybe Ashutosh, you can turn your camera off.
Okay. Yeah.
But we'll continue. Thank you for your feedback. Okay, let's try to keep.
So okay, sorry for the interruption. I was talking about my experience of burners in India. Those days, burners were very difficult to import. If you remember about 1970s, 1980s, it was very difficult to import burners in India or anything in India, actually. So we supplied 3 oil-fired burners to the client. And when the client started the burners won't start. So I went there, I looked at the burners, and we found that the burner design was pressure atomized. And pressure atomized does not work with natural draft burners. So we brought those burners back, changed the burner guns, designed steam atomized guns, and supplied it back. The third case was a burner for a air heater for a sulfuric acid plant in GSFC, Gujarat State Fertilizer. And when you supplied the burner and the heater operated, the flames started coming from the top of the stack. So we redesigned the burner, fixed it. But what I'm trying to talk about is burner design is highly complex. And there are only, if you all know, there are only 3 companies, major companies in this world, who supply burners for fire heaters. And they are all based in Tulsa, Oklahoma.
Sorry. One more quick. I think we're still getting some messages about like the audio is a little bit choppy. Is it possible for you to stop your camera maybe to reduce the bandwidth?
Stop the camera? I've done this webinar using the same computer almost so many times.
Yeah, it's just that maybe the internet or the bandwidth is a little bit.
Okay. Let's continue. And I think if you're not able to hear me, we will post this webinar on YouTube, and hopefully you will be able to take care of see it again. Hopefully, I do apologize. I don't see any issues on my side. You know,
Okay.
so, so as you know, all the burner companies are located in Tulsa, Oklahoma, and there are, offshoot of only one company, Johnson. So we will be talking about burners today, and this webinar is more about how to specify burners. This we have modeled it, or we are using API 535 as the base document. If you are not familiar with API is American Petroleum Institute, and every 6 months, a meeting takes users, engineering companies, and vendors to develop standards. So API 535 was first issued in around 1985, and since then today it is in the 4th edition. So we'll be talking about some of the specifications. How, if you are in the market for buying new burners, what should you be looking for? That's what our objective is. We will again talk about burner fundamentals. So let's move on. Before I start, I do need to talk about my company, because my team, my engineers have worked very hard for the past 1 month to prepare this presentation. So we need to do this little bit of infomercial for you. Furnace Improvements has been in business for almost 30 years now. We started in 1996 in Sugar Land, Texas. We have our main office in Noida, India, which we started in 2005. We have 3 patents. We have a split flow patent on increasing the capacity of fire heaters. Then the inclined firing technology is on burners, how to incline the burners and reduce the tube metal temperature. The third patent is efficiency improvement dampers. And how we work actually is a very interesting story I want to tell you. In 1996, when I got a chance to tour the Houston area refineries, Houston area has 6 refineries and almost like 300 heaters. And no company was looking at maintaining or taking care of existing heaters. Every company was looking at supplying new heaters. So we found this niche of talking directly to the end users, talking directly to people like you who are listening, and find out what is wrong with the heater, what is the issue. So we started an exercise of direct communication with the end users, doctor-patient relationship. And our focus has been improving performance of existing fire heaters, steam reformers, CO boilers. We work directly with owners, and we always try to provide unique value-added solutions. We take pride in doing high-quality technical work, keep schedules. Because of the time difference, we are able to work around the clock. And our philosophy is do it once, do it right. I encourage you, or I request you to send us your worst heater to us, and we promise we will make it the best heater. We have done it several times. So if you have a heater which is giving you troubles, which is not achieving efficiency, capacity, emissions, anything, send us the inquiry and we will make sure it is the best heater. We focus on refinery heaters, boilers, steam methane reformers, SCR units, ultra-low NOx burners. We focus on all types of combustion equipment in the refinery. We don't do sulfur plant units, sulfur heaters, but everything else. Most of our business is based in US. Our largest client is Phillips 66, but we have long relationship with Countrymark, Citco, Delek, Marathon, Hindustan Petroleum, and a lot of other refineries throughout the world. Another thing I want to talk about is Siddharth has worked for the past 6 months. What he has done is he has taken my 50 years experience and distilled it into 3 hours of training for operators. And I felt I can tell you that it is very important to train your operators continuously so that you get the best results. A lot of times when I go to the refineries, I find the operators telling they are afraid of touching the stack damper, they're afraid of touching the burner, so they just leave it fully open. And as a result, you have a very inefficient heater operation. So we have developed this heater fundamental class, about 3 hours for operators. They can do it anytime from their control room, from their home, and the pricing, early bird pricing, is only $95. So if you're interested in training your operators, please contact us for this operator training, online training. As far as engineering capabilities are concerned, we have process, CFD modeling, mechanical structural design, 3D modeling. We do turnkey projects. It's not just consulting or engineering. We do design, engineering, supply, and if you want, we can even take care of the erection. So we do complete projects, and we can do the project very fast, anywhere between 8 to 12 months. We do a lot of CFD. Our strength is process. So we do combustion, airflow distribution, fan suction, discharge ducts, AIG, and SCR units. Already talked to you about the technology. So inclined firing technology is related to burners, and we incline the burners anywhere between 3 to 7 degrees. You can see over here. And just by inclining the burners, we are able to get almost 100 to 150 degrees at lower tube metal temperatures. We have installed it in about 12 heaters now. Okay, so let's come back to our burner webinar. This is the course my team has put together. We may change a little bit, but we will talk about burner fundamentals, burner components, burner selection considerations, burner firing, loan-off burners, burner operation maintenance, burner testing, and burner troubleshooting. So we'll try to complete this course in about a year's time, 8 classes or maybe 10 classes, we'll see. But that is what we are trying to do over here today. So today's agenda is basically talk about API 535, talk a little bit about fired heaters, burners, fuels, air, flames, and all those types of basic things we will be talking about today. So I already talked to you about API 535. And what industry is trying to do is to kind of put all their collective wisdom together and come out with burner specifications. The first one came out in 1995, first edition. Then second edition came out in 2006. Third came out in 2014. And the next came out just recently, I think it was 2024. If you don't have a copy of API 535, I suggest you should buy it. It's a very good document, and you can even call it a Bible on fire heaters. Covers all type of burners, cover all types of configurations, sound engineering practice, especially if you are planning to buy burners or buy heaters, then you need a good information or good source of information and specifications for burner, and API 535 is a really good document you may want to have. So getting back to fired heaters now. Fired heaters are largest consumers of energy in a refinery. Most fired heaters will consist of three components: radiant section, convection section, and stack. Some heaters may not have convection section, but those are startup heaters. In fired heaters, what we are doing is we are burning fuel with combustion air to generate heat. And this heat is transferred to the fluid in the radiant and convection sections. And cold flue gases are vented to the atmosphere through the stack. This is a picture over here of a vertical cylindrical heater, 4-stroke. You can see the small stack ID fans. So what is a burner? A burner is a device for combusting fuel gas, fuel air, or any fuel with air or with oxygen also in a heater or a combustion chamber and produce the desired flame pattern. That's basically the function of the burner. You want to make sure that the air to fuel ratio is correct, the flame shape is correct, the combustion is stable, and it ignites safely. So there are a lot of some of these requirements on burners which should be done. And as I said, burners are heart of fired heaters. If you think about the cost of the burners, most of the time the cost of burners is insignificant as compared to the heater cost. If your heater costs $10 billion, the burners may be no more than 600,000 to 800,000, maybe $1 million. So in terms of capital expenditure, the burners are much lower, but they are very important component when it comes to the operation of fired heaters. So mankind has known combustion for, I don't know, 10,000 years, something like that. And combustion has been central to human survival. In the day, you get sunlight, but in the night, you have to have fire or combustion to generate heat, to generate electricity, So combustion is very basic. And it needs three things. It needs fuel. Then it needs oxidizer or combustion air and a source of ignition. One thing which I have not told you is the fuel and air needs to be in the right proportion. And what happens in combustion is chemical energy gets transferred to thermal energy. So our fuels are hydrocarbons, liquid or gases. Oxidizer is combustion, air or atmospheric air. Air has 21% oxygen, 79% nitrogen. And combustion is a rapid oxidation, irreversible reaction. That's the definition of combustion. I'm sure most of you would have experienced Bunsen burners in your high school or college, Bunsen flames as a part of the chemistry class. So what is our function or objective? Achieving clean, efficient, and stable combustion in fired heaters. That's what our practice is. There has been a lot of change in the industry over the past, I would say about 100 years, I should say. So in the old days, the fuel used to be mostly gas, but it was supplemented by fuel oil, because fuel oil was a byproduct of crude distillation. So most of the burners used to be combination burners or fuel gas fired burners. And that's how the industry worked actually. But people realize that oil causes a lot of pollution, lot of nitric oxide emissions, nitrogen oxides, lot of sulfur acid DuPont corrosion, sulfur oxide in the atmosphere. So fuel oil has practically been banned in most of the parts of the world. There are some places where you do fire fuel oil. I'm thinking in somewhere, some clients in Europe, some clients in Asia, South America. We did a project recently for Jamaica, so they had fuel oil firing as an option. So, but the things have changed, and most clients fire fuel gas now. Mostly it is natural gas, but it could be other gases also. In refinery, you fire whatever you cannot sell. So you do in your refinery fuel gas, you have anything and everything which cannot be sold is put into the refinery fuel gas header, and that's what you fire. So fuels produce different fuels produce different type of flames. Liquid fuels typically will produce luminous flames. Gaseous fuels will produce non-luminous blue or pinkish flames. I don't know how many of you have experience of fuel oil firing, but there is a difference of day and night between gas firing and oil firing. Oil firing is very, very difficult. So from one sense, once the fuel oil has been banned, I would say it is good riddance. The life of operators, the life of engineers have become a lot easier with gas firing. So I'll stop at that. I can continue on burners and fuels and keep on telling you stories about my experience with fuel oil firing. But let's move on. So liquid fuels can be light naphtha all the way to heavy fuel oil. Number 6, And typical composition of carbon, hydrogen, sulfur ash. What my team has put over here is a very clean fuel oil composition. I remember while I was in India, we used to burn heavy fuel oil, which had a lot of sulfur, almost to the extent of 5%, not anymore. And we had sodium and vanadium, high sodium, high vanadium fuels, which would cause lots of issues. As far as oxidizer is concerned, I think we are very lucky that combustion air or atmospheric air is free. Some people may put oxygen if they have instead of air, so they do that. Some people use preheated air to improve the overall efficiency. They install an air preheater. There is also some installations where we have used flue gas recirculation to reduce the NOx. So typically anywhere between 15 to 30% of flue gas is recirculated to reduce NOx emissions. So I said in the beginning, when I talked about combustion, that one of the things which you have to watch out is the right proportion of air and fuel gas. So you have to make sure that the proportion of fuel and air is at the right. So industry has two limits, LEL and UEL. LEL is the lower explosive limit or lower flammability limit, the minimum concentration of fuel in air which can ignite safely. Below this, the mixture will not burn. UL is the upper explosive limit, the maximum concentration of fuel in the air which combustion can occur. So you can see you have to make sure that you are either below between LEL and UEL. I don't know if you remember that anytime there is a shutdown in the industry, the safety guys go to all the equipment, enclosed equipments, and check the presence of combustibles. You know, they have an explosive meter, they check the combustibles concentration, and then they declare it is safe to enter, you know, or it is safe to start the heater. So that's what they do. They're basically checking you are below LEL. These are the limits of different fuels: hydrogen, methane, ethane, propane, ethylene, butylene. And you should look at the first one and the last one. They are both very explosive. Hydrogen anywhere between 4 to 75%. Acetylene between 2.5 to 81%. So you can see how these things could be dangerous if you don't treat them carefully. Okay, once we have the fuel, we have the mixture, we can have three conditions. First one is stoichiometric. Stoichiometric means you give the right amount of air, right amount of fuel, and you want the things to burn, you know. Now, if it was a perfect word and you had unlimited residence time and unlimited mixing energy, you would get a good flame, you know. But in the real world, it won't be perfect. I can tell you of my experience of doing stoichiometric combustion to produce inert gas. We used combustion to generate inert gas, and stoichiometric mixture or substoichiometric mixture combustion is very, very difficult. So most of the time what you have is lean mixture, you know. You give excess of air. Air is free, so you can afford to give excess of air. And that ensures that the combustion is complete. But if you give too much excess air, you will be losing heat actually, because you will be heating up that extra air or extra nitrogen and air. So you have to make sure that you are in the right. And then you have the rich mixture, you know. What you do is if you try to put more fuel and this thing, most of the time you will have CO breakthrough taking place. You will have a high CO slippage, you know. Industry puts a limit of 50 ppm for CO. CO is poisonous too, you know. So we have to make sure that we don't exceed more than 50 ppm CO in our combustion. So this is a typical refinery gas. And these days, or not these days, for the last 20 years, refineries have been generating a lot of hydrogen. And if they don't have any use, they will put it into the fuel gas. So in US, I have seen hydrogen concentration anywhere between 25 to 50%. This is a different fuel gas, has 32% ethylene, which normally is not there, you know. So, but fuel gas in refinery is a dumping ground, you know. I don't need to go over these. These are simple chemical reactions, you know, balanced equations. All of you know we have hydrocarbon plus oxygen plus CO2, and complete combustion produces carbon dioxide and water vapor. So these are equations. I mean, we can add nitrogen also. If you want, we can add, for each molecule of oxygen, we can add 3.79 molecules of nitrogen. So that can be on this side as well as on this side. Nitrogen does not take part in the combustion reactions. More equations. When you burn hydrogen, you don't produce carbon dioxide. So that's the benefit. Everybody is talking about hydrogen burning now, you know. For the last 30 years in US, the stress was on NOx, you know. Reduce NOx, get low NOx burners, get SCRs units, get all those type of things. And suddenly in the last 5 years, even though we knew it for 50 years, the stress has been on CO2 removal. They are saying that if you don't reduce the CO2 concentration, the global warming will take place. So now the issue is reduce the formation of CO2 or produce CO2 but then recover it and put it into the ground, you know. So things have been changing actually. Things have never been the same, you know. I mean, that's what I saw actually. We had spent almost last 30, 40 years working on NOx. You know, NOx was actually only in ppm, you know, maybe 500 ppm at the most to 100 ppm, you know. But when you talk of CO2, we are talking of 10, 12% of CO2 being generated in the combustion, you know. So anyway, let's continue. You know, I get deflected. So heating values, you know, we have different heating values. I'll just talk in a minute, but these are the heating values of hydrocarbons. You know. And if you see a trend, you will see they're more or less everything is around 20,000 pounds BTU per pound, you know, 2021 when it comes to the pound. So that's really good actually in one aspect that per pound basis, all these compounds, they generate almost similar amount of heat. So what is HHV and what is LHV? LHV is the lower heating value and HHV is the higher heating value. Lower heating value means when the flue gas, what we have generated, has carbon dioxide, water vapors, nitrogen, and oxygen. These are the 4 components. So when the water vapors remain in the vapor form, the amount of heat released is known as lower heating value. And when those water vapors are condensed, giving out additional heat, then we call it a higher heating value. So lower heating value is higher heating value minus latent heat of vaporization. And a thumb rule in the industry is higher heating value is 10% higher than the lower heating value. Just to note one point that heater industry, the refining industry, sorry, I should say the heater industry, or the process industry works on the lower heating value basis, LHV basis. The utility industry, the boiler industry, and the EPA, they all work on the higher heating value basis. That's a difference. I don't know what is the reason. Maybe the boiler people came first. You know, boilers have been there for 400 or 500 years. So whatever boiler people did, that became standards, and then, you know. But you just need to be made clear about what is LHV and what is HHV. Another thing we want to talk about is Wobbe Index, and it is an index to show whether gaseous fuels can be interchanged. You know, so this was more applicable when we had premix burners. And if you are aware or not, I think 60, 70 years ago, or maybe 80 years ago, everything used to be premix burners in the refinery. And that's where Wobbe Index became very important, like interchangeable. Suppose the refinery fuel gas composition changes, you want to make sure your burners will still be working. So Wobbe Index was basically high heating value divided by the specific gravity square root, square root. And if you are within plus minus 5% of the Wobbe Index of the design gas, you could fire the same fuel without making any major modifications. So that was the significance of Wobbe Index. It is not relevant in raw mix burners, nozzle mix burners, or all these natural draft, ultra low NOx burners. There are very few pre-mixed type of applications. So these are the Wobbe Index, and you can see hydrogen or methane. So you can see methane, you cannot substitute propane, or vice versa. So you can see hydrogen and methane are pretty close, but still, you want to make sure they're still about 20% off. You just want to be 5% off. So let us see what we get out of combustion. First of all, the combustion products are known as flue gases. I'm hoping all of you know that actually. So there are several components. Carbon dioxide is the main, could be 8 to 10% in gas fired, 10 to 12% in fuel oil fired. Water vapor, 10 to 12% in natural gas, 8 to 10% in fuel oil. Oxygen, typically 1 to 3%. In fuel oil firing, it will be higher. Nitrogen, 72 to 75. Fuel oil, it will be little less. And then we have pollutants, carbon monoxide, NOx, sulfur dioxide, unburnt hydrocarbons. So these are the important pollutants, and we have to ensure that their concentration does not go higher. I mean, if you see over here, CO could be an issue, with oil firing. NOx definitely is an issue with oil firing. Sulfur could be an issue, yes, if sulfur is there in the fuels, and unburnt hydrocarbon. And as I said, oil firing is very difficult, so thank you. We are not doing oil firing anymore these days. We are only struggling with gas firing. So another parameter you need to make sure is, or understand, is what is ignition temperature or auto ignition temperature. So that auto ignition temperature is the lowest temperature required for the fuel in the air to spontaneously ignite in the absence of ignition source. So if you heat the methane to about 1300 degrees along with the air, then it will automatically burn, So these are the temperatures, At this point, you don't need an external source of ignition. It will ignite automatically. Flame temperature, very, very important parameter, or what we use it. So flame temperature is the theoretical number when you take the heat generated by the fuel and divided by the flue gas mass and the specific heat. So that's what we have. So actual flame temperatures, what we see or measure, are much lower because of the heat losses. So hydrogen burns all very hot. Acetylene, if you see over here, burns at 4500 degree F. And I'm sure you must have heard about oxyacetylene torch for cutting metals. And one of the reasons we use acetylene is because it's the hottest flame. But even if you see, all these numbers are very, very high. There is no material which can stand these temperatures. 3,000, 4,000 degrees is very, very hot. What is flame? So flame is a visible portion of combustion reaction. That's basically the definition of flame. Combustion may be taking place all over, but the visible portion or the hottest portion of the flame, we define flame as a 2000 ppm CO boundary layer. That's another definition. And flame speed is at which the flame front propagates through the combustible mixture. In steady state, flame speed is equivalent to the velocity of the gas-air mixture. If the fuel air rate is very high, flame may get blown off. So here, methane, ethane, they all burn at the same speed. Acetylene, you can see, burns at almost 4 times. We are missing hydrogen in this table, but hydrogen even burns even faster, 7 times, almost like 7.5 feet per second. So hydrogen burns very fast. That's what something you have to kind of take note of it. If you're thinking about burning hydrogen in your heaters, think about the flame speed. Flame color. Flame color is also very important. And most of the time, it is the function of the fuel you are burning. And gas burning and oil burning, they both follow different routes for combustion. Gas has hydroxylation process, and oil burning is a 3-step process where oil is first atomized into small particles, then it is vaporized, and then it burns. So a lot of times when it is vaporizing, it turns into soot, and that soot which burns gives a luminous color to the flame. So most of the time you will see luminous flames in oil and non-luminous flames in gases. I don't pay too much attention to the flame color as such. Hydrogen flame is practically colorless. You won't be able to see it. Oil flame you can see very easily. The most important thing you have to ensure is the flame stability or the burner stability. That's very important. The flame, whatever it is coming out, should be stable. Should not be like in spurts. It comes, it goes, it comes, it goes. That's not good actually. So make sure the burner flames are stable. These are a number of other parameters. I don't want to go into detail. Burner flame envelope, flame length, flame front, flame stabilization point, flame liftoff. I think most of these things are defined in APF 535. And as I said, getting a copy of APF 535 will be good for you to read and understand all these points. Flame liftoff. When does the flame lift off? When the fuel gas velocity is higher than the flame velocity, the flame will lift off the tip. And if it's very high, then the flame may even get extinguished. So blow off is when as I just said, the flame velocity, the fuel gas velocity is very high, then it will this. Flashback, people worry a lot about flashback, but it is not important these days because we don't have premix burners. Flashback happens mostly in premix burners, or it happens in pilot burners also once in a while, but very little. So you have to make sure, especially hydrogen, you have to be very careful because the hydrogen flame speed is very high, 7 feet per second. So if your mixture is going out at 6 feet per second, it will be flashing back. Swirl number is angular to axial discharge momentum. Basically, it tells you about mixing, air fuel mixing. The swirl number becomes important. I think we can stop here and see if we have any questions. I would like to answer questions and then continue for a few minutes if we have time. I see we have got 3 questions. Anybody else has any questions?
Yeah, please submit your questions. I can ask one of the questions. Okay, one of the questions is, burner manufacturers always claim excess air at turn down case to be very high, between 200 to 300%. So what is the technical reason behind having excess air, and how can we reduce it?
So thank you for the question, Siddharth. There are 2 or 3 things. When you're burning on turn down, the velocities become very low. And as a result, the mixing energy becomes very low. And we need to supply a lot more excess air to complete the combustion. So that's the reason at turn down rates, the excess air could be even 10% O2. That means 100% excess air. You can try to minimize it, or you can try something else also. Other things. I see there are 3 questions. Let me see. What is the best way to? Okay, we have lots of. Okay, what is the best way to operate a combination burner? The best way to operate a combination burner is to operate some burners on gas and some burners on oil. Or you can base load one of the fuels. You could also make sure that your gas is oil is base loaded. If oil does not change, and all the variations are taken care by this thing. What is the recommended HC ratio in case some plants want to mix excess? Excess hydrogen in any fired heater. I think that there is no issue with respect to hydrogen. You have to just make sure that we have the right, proportion. Burner turn down ratio, I think Siddharth just mentioned it, Okay, let's see. Yeah, turn down should not be, I see you're saying, but turn down should not be, there's very little things what we can do, Yeah. Okay, anything else we want to talk about?
Hey, there's another question.
Yeah, go ahead.
This is for steam methane reformers. Okay. At turn down, usually H2 goes up in PSA tail gas, which is burned in the reformer fire side, but that results in a rise in NOx. Are there any easy solutions to this issue?
No. I think because what is happening is when the burners are designed, they are mostly designed for one composition, and the NOx is a function of flame temperature. So when the hydrogen goes up, the flame temperature goes up, so the NOx will automatically go up. It's very hard to control that, because once the burner is designed, the combustion characteristics are fixed. Now we cannot change it unless we want to put hydrogen in the staged fuel gas tips, which may not be possible. Yeah.
Okay, here's another question. What are the best practices for minimizing NOx and CO emissions from burners?
So I think there are two opposite objectives, you know. If I want to minimize NOx, I want to reduce excess air in the heater, but if I want to minimize CO, I want to increase the excess air, you know. So you have to kind of balance the two, because if you do one, the second will, you know. So these things are normally taken care during the burner test, and we will talk about it later in the burner testing. But once the burner is designed, all you can do is to ensure that if you want to minimize NOx, you will have to reduce the excess air. Just make sure that CO slippage does not take place, you know, at those two conditions.
And then there's a second part, maybe one last question. What are the early signs of burner malfunction or degradation? And how often should burner components be inspected or replaced to ensure optimal performance?
So, okay, good question. I think what you need to do is check the parameters like fuel gas pressure, fuel oil pressure, steam pressure, and see if you see a change, you know. That will be one. Second is to observe the flame pattern in the heaters, because if your tile is damaged, you will be seeing a different type of flame, you know. You will be seeing a flame going not straight, but maybe here and there. Or if your tips are plugged, you will be seeing. So if you do a regular inspection of the burners, maybe once a shift, we suggested preferably at night, you will get better results, you know. You will get much better performance out of the burners. And every turn down, you can check the burner component, especially the tips, you know. Those are the most prone to coking. They are most prone to, if you have size increase in the tips, you know. Normally it happens only with fuel oil, not with gas, but it can happen, you know. Or you may have high temperature degradation of the tip. That's what can happen.
All right.
All right.
Well,
Thank you very much. Yeah. Yeah.
Oh, no. Yeah, I was going to say the same thing. Thank you all for joining, for submitting questions, for staying engaged. Sorry for the couple of audio issues, but I think it all kind of worked out. There will be more webinars on this burner series. So we'll send out updates when we have more burner webinars in the future. But please reach out with any questions that didn't get answered. We'll post this webinar to YouTube as well, so you can watch it over in case you missed anything. But please reach out if you have any questions or want more specific guidance. We're happy to help. So thank you all for joining.
Thank you.